Okay, so let's try our example with the basically reservation station and register a listing table and how they work together. All right, so let's assume that the process is fully pipelined with 4 stages: fetch, decode, execute, and write back. By the way, this question is heavily inspired by the undergraduate level computer architecture class exam at CMU, which I was a TA for. I think it's like 2014 or 15, but it's a little bit different from that. And then for this particular question, right, for our instruction, fetch take 1 cycle, decode is 1 cycle, write back is 1 cycle. Add and multiply is also there. Add would take 3 cycles, multiply is 4 cycle. Okay, and a quick note is these are fully pipelined. So actually, let me change the editor into Microsoft Edge so I can draw on it easier. Where's this? Open with Edge. All right. Okay, so this allows me to basically draw on the PDF. Okay, so add take 3 cycle, multiply is 4, is fully pipelined. Everything else, fetch, decode, and write back is all 1 cycle. All right. And then just quick note, you have fetch, then decode, then execute, then write back right away. There's no memory here. Okay. Instruction always allocate the first reservation station that's available from top to bottom. Okay. And let's suppose that initially everything is empty. Right. We have the data flow graph. It looks like this. What are the operations? So the first operation is you want to add, right? Add R5, R6, and you write the result into R1 because as you can see, this is R1, right? Then you do Then you do the multiply, right? You multiply R1 with R6, right? Then you have the result of R2, okay? Then you see that the third line, I have a hint because both can be done at the same time, right? The multiply and the add, but you see that one of the source for the multiply is going to be R1. So you know that the third instruction is going to be the multiply and the fourth instruction will be the add, right? So the multiply, you want multiply R1 with R2 and you write the result into R4. Then you add R2 and R5, okay? And write the result into R4. Again, you see how you have R4 back to back here, okay? And then you perform the multiply, okay? You multiply R4 with R4 and write the result into R4. All right, you see that first of all, there's multiple versions of R4. There's going to be some data hazard here, but the reservation station and the register a listing table will fix the issue for us, right? Your task is to basically fill in the state up to cycle number 9, okay? Up to cycle number 9. So let's see what happened when you start to run your program. Again, your program, going back up, this is the program. The first instruction is the add. So the first cycle, I fetch instruction 1, right? Instruction 1 is being fetched. When I fetch, right, I fetch this into my basically reservation station, right? It's an add instruction. The next thing is I decode them, right? Basically, I decode the first instruction, fetch the second instruction. The second instruction, when it's being decoded, I know that's an add instruction. What do I need? I need R5 and I need R6. Okay. Initially, everything in the register, right, will be valid. And the value, let's assume that initially like, everything is has a value from 0 to 7, right? So it's going to be 0, 1, 2, 3, 4, 5, 6, and 7. Okay. Now, with the first instruction, you want to add R5 and R6, right? So it needs R5. So I want R5 here. The tag is R5. Value is going to be 5. I want R6. Value is going to be 6, right? And this is valid, right? It's valid. What do I write back to? I want to write back to the add. This is going to write back to R1, right? So I know that for the RAT, right? I know that R1 is going to be updated now, right? With the new value. Sorry, I erased too many things. So you know that the first add here, the tag A is going to produce R5 plus R6 for you. It's not valid yet, right? Because I need R1. The tag over here becomes A. Basically, it means that whoever needs R1, go look at tag A, right? And now the value is going to be unknown. I don't know what's the value here yet. I'm adding, right? Because add take 3 cycles, it's going to keep doing this for a while, right? So it's going to be executing here. Instruction 2 is decoded. Instruction 3 is fetch. Instruction 2 is being decoded in cycle number 3. That's the multiply instruction. It needs R1 and R6. Do we have R1? No. Do we have R6? Yes. So instruction 2 is doing an add. I need R1. R1 is not available. I look at R1 at the table and say, okay, where is R1? Who holds R1? R1 is in the tag A, so I know that tag A has R1. The value is not there. It's not valid. I don't know the value here. Let's just say I put in x here so that I don't care. I don't know the value. And R6 is valid, right? So the value is 6. Basically, now you record in the reservation station for the multiply saying, I want to do the multiply. I want the value of R1. It's not there, but if I want this is basically from tag A. Then from the second input, I have R6, so that's ready. Okay, so I cannot dispatch this guy in cycle 4. I don't have the input. I can execute here. I can decode this guy and fetch this guy, right? So I decode the third instruction. That's a multiply. I need R2 and R1. The second multiply, I need R2 and R1. I have R2. It's valid. The value is 2. I don't have R1. I need the R1 from A. Okay. Again, I don't know the value of this. It's not valid. And then one thing I forgot is the second instruction, the multiply, want to modify R2. It modify R2. So this would actually make R2 becomes invalid. All right. I make a quick mistake here, right? So R2 is modified by the second instruction. This multiply here, right? This multiply here is modifying R2. So I need to update the register aliasing table saying, hey, if you need R2, it's not valid. But if you want it, it's in the entry tag X from the multiply or reservation station. I don't know the value here, right? I don't know the value here. And I need R2 here. I'm going to take it from tag X, and I don't know the value here yet, all right? So for the third instruction, again, I cannot do anything here. I cannot do anything here. I can execute here, right? I can execute here. Then I can decode the fourth instruction and fetch the fifth instruction, okay? Then when I take the fourth instruction in, is the add, I need R5 and R2. Do I have R5? Yes, I have R5. Actually, one more quick thing. The multiply modify R4. So R4 over here is going to be now updated, right? Updated with the new tag. And it's not valid anymore. If any one of you need R4, go to the tag Y, but I don't know what's the value yet. Okay. Then the fourth adds come in. I need R5 and R2. Okay. Who has R5? I look at the entry. R5 is there, right? R5 is there. And the value is 5. But when I look at R2, R2 is in what? Tag X. I don't know the value yet, right? And what does it modify? The add instruction modify R4 again. So I can then erase this entry. It's not available at Y at anymore, right? It's not available at Y anymore. It's now at B. So if you need R4, look at B. I don't know the value of this yet, right? Then the last instruction, basically now you're done. You in the memory, the write back stage here, right? You finish instruction 1. Okay, so something can be done with any instruction that needs tag A. What do you mean by that? If you look at these table here, you see that someone actually requires tag A, right? Someone requires tag A. This R1 here is actually being needed by the 2 multiply, right? So to do this, you know that, okay, who needs a take it? That's broadcast in the common data bus by this guy, which is seen by everyone, right? So for any entry that said A in the table, any entry that say I need A in the table can now be replaced with the actual value of A, right? So over here, R1 is now valid. Tag is still the same tag, it's A. The value of R1 is going to be 11 now, right? So if you need A, it's valid now, tag A is 11. It's valid, tag A 11. Now this instruction is ready. So you can start to execute here, right? You can start to execute here. I cannot do anything with this instruction. I cannot do anything with this instruction. I decode this instruction. The last instruction is the multiply. I want to multiply R4 with R4 and write the result back to R4. Who has R4 right now? B, right? So I said it's not valid, tag B, don't know the value, not valid, tag B, don't know the value, and then I will update R4 by saying it's not this, it's again not valid, right? But the tag that has the most updated version is C, right? Then I keep the execution going. So I execute this guy. I cannot do anything here. Nothing is ready, right? I cannot do anything here. Cannot do anything here. Execute. Cannot do anything here again. Execute because multiply takes 4 cycle. Okay. Cannot do anything here. All right. So that's how you can complete this question. Let me finish the whole thing. Okay. So after this cycle, instruction 2 is done. The multiply is done. So when the multiply is done, we say, okay, who need X, right? Because that's the second instruction. This one is done. You will say, who need X? Please replace X with my result, which is 66, right? 11 multiplied by 6 is going to be 66. So I'll replace any occurrence of X here, right? And there's one here. Who else needs X here, right? With 66. So I will say, okay, if you need X, it's valid now, right? The tag is X, and the value is 66. Give us one more here. Okay. It's now valid, tag X, 66. Valid, tag X, 66. You see that both Y and B are now available. They are actually on a different ALU. One is add, one is multiply. So I can actually perform both instructions, right? I can execute this guy and this guy together. Then just write back. I'm done, right? As you cannot do anything here, I'm waiting for R4. Execute, 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 right? I cannot do anything here still. Let me go back quickly. Instruction 3 is multiply. Instruction 4 is an add, right? So instruction 3 is a multiply. That finished first. Oh, no, that's finished last. I still need to execute this guy. This is done. I cannot write back, all right? I cannot write back because I need to finish instruction 3, write back before instruction 4, write back. So I wait. But I have the value ready. It's an add instruction. I'm trying to do adding 5 to 66 and tag B. So it broadcasts whoever needs tag B, which is R4, right? Tag B, R4 here. You can then take the value. Sorry, I erased too many. This is still tag C. I don't know the value. But if you need tag B, right, it's now valid. The tag is B and it's 71, right? Valid B 71. Now this becomes ready. So you can now execute this instruction. This one can write back. Okay, I am done with the third instruction. That's the multiply. No one need tag Y at the moment. So it's clear out, right? But no one needs Y. I can then, I don't do anything here. I only have one write back unit. I can write it back here, execute, execute. And if I remember correctly, that's a multiply. So I need one more cycle before I can then write back. And now that I write back everything, right, I would update R4 here with the correct value, saying if you need R4 from this point on, I have the value is valid now. And the result is basically 71 multiplied by 71. And that's the whole thing. All right. So that's it for the out of order execution. As an example, it's actually, again, it's pretty straightforward. The idea is to make sure we go through the steps and hopefully make sure the write back still happen in order. All right, the write back should do like it like that. You wait until you can retire the instruction in order. All right, so I guess I'll stop the recording for now and we do a longer Q&A about this particular questions, right? And then we can do the question in Thai or in English. I'm okay with that. Okay.